before we get started, are there questions over the homework? We're good? All right.
I said appreciate it, and you were doing your maxilla.
Now, what we're looking at today are three properties of logarithms. And the first one is our product property. If we have two or more things multiplied together inside the log, we can rewrite it as an addition of logarithms. So log base b of m times m is the same as log base b of m plus log base b of n. Our quotient property, if we have log base b of m divided by n, two things being divided inside the log, we can rewrite it as two logs being subtracted. And our term on bottom would go second after our minus. And our power property, log base b of m to the n is the same as n times log base b of m. We move the exponent to the front. Questions on these here? These are our three properties, and we're going to use them to expand the logarithmic expression. Now, the order in which we use these is going to be, first is our quotient. We're going to use our quotient property first, our division property first. And after we finish doing the quotient property, we're going to do the product property, our multiplication property. And the last one we're going to use is our power property. When we're expanding, it's going to go quotient, product, power. Quotient, product, power. So if we look at this first example here, the natural log of 5x to the 7th over y. If we do our quotient property, we could rewrite this as subtraction. So we'll have the natural log of the numerator, the top of the fraction, 5x to the 7th, minus the natural log of the denominator, the bottom, which will be minus the natural log of y. Questions on this so far? Okay, so there's no more division. We've taken care of the quotient property. Now our product, well, natural log of y is already by itself. We won't apply it to it. But our first expression, 5 times x to the 7th, we have two things being multiplied together inside the log, so we can rewrite it as addition. So it'd be the natural log of
5
plus the natural log of
x
7. Yes. So we'd put an extra log in for each one. Because even though the general definition of it has log base b, this is the same with natural logs. All the properties still hold true. Do we have anything else being multiplied together? No, we have 5m, or 5x and y, yes? So we move on to powers, our exponents. And our one exponent that we have is the 7th power, so we would move it to the front, telling us that we have the natural log of 5 plus 7 times the natural log of x minus the natural log of y. Questions on this here so far?
I think I
and we're good. And the ones that have the minus in front of it would be in the bottom. Even if we had multiple terms, we'd have multiple expressions with minuses. We ready for the next part? That's it. Because it's all simplified down. Each logarithm only has a single term in it, no exponent, so we're done. Almost. Yes. So the first thing we would do in the order is quotient. So we'd have natural log of the top, which would be 3x to the minus the natural log of the denominator, which is y. That's all of our division. Now the first one, we do have a product, which would be the natural log of x to the fifth minus natural log of y. Now from here we can use our power property. It wouldn't affect the natural log of 3 plus 5 natural log of x minus the natural log of y. Questions on this here? We ready for the next one? So the next one we have is log base 6 of 3x to the fourth. So the first thing we would use is our quotient property. Yes? Do we have anything being divided inside the log? So do we actually need to use the quotient property? No. So we're going to skip the quotient property and go straight to the product. And if we use the product property on this, we'd have log base 6 of what? X to the fourth plus log base 6 of 3. Because since we have 3 and x to the fourth being multiplied together, we can write it as the addition of the two logs. Log base 6 of x to the fourth plus log base 6 of 3. Now our power property would do what? Remove the 4 to the front, then have 4 log base 6 of x plus log base 6 of 3. Questions on number 5? Questions on anything we've done so far? Let's look at the next one. Natural log of 5 over the natural log of 5 over 12x.
Should be natural law of 5 minus natural law of 12 minus natural law of x.
Yes. Because if we broke it all the way down, yes, that would be it. Because we would, just using the quotient property, say natural log of 5 minus 12, natural log of 12x. And if you wanted to break it all the way down like that, yes, that works just fine. Because then our next would be our product property, which would give us ln of 5 minus what? Ln of 12 minus ln of x. Because that negative is being distributed through both. Because the way that we could think of this is more like this with our plus. Because we're really saying that those are being added together, but the negative out front has to be put to both, giving us this here. questions on this here? Condensing. When we condense, and I've gone through different ways to do this, but we're only going to use two properties to condense. Now there are some setups that it's easier to use just the one that we're not going to use, but when we do this here and we condense, the first one, I think it's easier to use as powers. And we want to take the negative. Take the negative with the power. We want to take the negative with the power. So if we look at the first one here, we want to condense this. We're wanting to make it into a single logarithm. We'll do powers first. Well, log of 9 does not have any powers or a number in front of it to move back up as an exponent because we're just doing the opposite. But the middle term has a 3, so we would move it back up. Plus log of 2 to the third, or 2 cubed. Now, even though the last one doesn't have a number in front of it, we want to take the negatives with it. Because I think it's going to be easier to work with a negative exponent than it is to try to regroup or have multiple negatives there. Because if we do this, it makes the last one be log of 3 to the negative 1. And what would our sign be in front of it? Plus. Because we took the negative up to the exponent, so it's now plus. Yes? Well, our next one we're going to use is product. Now, even though we only had the property stating two things being multiplied together, we can do the same thing with 3 or 4 or more. Because since we have 3 logarithms with the same base being added together, we can rewrite it as a single log with what's inside of each one being multiplied together. So log of 9 plus log of 2 to the third plus log of 3 to the negative 1 is the same as log of 9 times 2 to the third times 3 to the negative 1. Yes. Now, if we did simplify this, the numerator we can keep as 9 times 2 to the third. We will simplify that, especially in the calculator later. But the 3 to the negative 1, to get that exponent positive, we have to move it from the numerator to the denominator, giving us this here. Well, inside this logarithm, 9 times 2 to the third over 3 is all numbers, yes? So the calculator, figure all that out, 9 times 2 to the third over 3, it will simplify it for us to 24. Log of 24. And that's it. That's our final answer. Because when we move something from the numerator to the denominator, because x to the negative 1 is equal to 1 over x to the first. But the first power we don't have to write, because 3 to the first on the bottom or just 3 are the same thing. Any other questions on this first one of condensing before we look at the next one? Log of 6 plus 4 log of 3 minus log of 3. So again, we can do powers first. Well, log of 6 is going to stay log of 6. Plus, we move that 4 back up to an exponent, giving us log of 3 to the 4th. Plus 3 to the negative 1. Now, for most of the ones we'll do here, this doesn't make a big impact, but if we did have 2 or 3 minuses, it does help us keep track of all of those, what's going to be in the bottom. Now, since we have 3 things being added, we can move on to our product, which is rewriting this as a single log and having what's inside of each of the logs being multiplied together. And then to make that exponent positive, we move it from the numerator to the denominator. And again, we could have done 6 times 3 to the 4 times 3 to the negative 1. Well, let's try that again. 6 times 3 to the 4th times 3 to the negative 1. There we go. Or we can say 6 times 3 to the 4th all over 3, which is still 162. Now, if this is variables, we're going to have to do some of that calculations by hand. Questions on these two here? Are you ready for the next one? No? Huh? You're good? Yep. If I ever skip ahead and you need to go back, just let me know. Okay. Log of x minus log of 9. Now this one here, is actually easier to just use the quotient property. Because quotient property says that log base b of m over n is the same as log base b of m minus log base b of n. So if I use that property, what would this be? Log of, because when we subtract, have 2 logs of the same base being subtracted, it's the same as what's inside of them being divided. Now we could have gone, and we can still use the properties that we've been doing. Do our powers first. So we bring the negative up, telling us that this is log of x plus to the negative 1. 2 logs being added, so that is what's inside is being x times 9 to the negative 1. Well, to make that exponent positive, we move the 9 from the numerator to the, giving us log of x over 9. So there is some cases where we could have just, like this here, used the quotient property and gotten straight to the answer. Because those 2 steps work better when we do have multiple subtractions or a lot of terms we're trying to keep track of. Questions on this here? Number 8, natural log of 4 plus 3, natural log of 3 minus the natural log of 12. So condensing, we use power property first. It'll still be ln of 4 plus 3 to the third. Plus ln of 12 to the negative 1, because we bring the negative to the top, and we bring our 3 to the top, our exponents. Now we have 3 things being multiplied together, yes? So this would be ln of
4 times 3 to the third is 12 to the
Now if we wrote this out, 4 times 3 to the third over 12. Now if we plug that into a calculator, we would get 9. Well, 12 is what? 4 times 3, yes? 4 on top and bottom would simplify, and one of the 3's on bottom would simplify with one of the 3's on top, just leaving us with 3 squared. Well, 3 squared is 9. the calculator would do that for us also. Questions? All right.
That was missing a word.
We do have two things left. This here, they gave us the value for log base 2 of 3 and log base 2 of 7. So we're going to use those. And I want to use the properties that we have of logarithms to get there. So for the first one, we don't have anything to do that we need to do to it. But the other two here, 21 and 49, we need to rewrite them using multiplication or exponents so that we get with 3 and 7, either 3 squared, 7 squared, 3 times 7, any of these here. Now our first one, log base 2 of 3 divided by 7. That would be our quotient, yes? And by the quotient property, it's telling us that this is log base 2 of 3 minus log base 2 of 7. Questions on part A so far? So we're good with going from log base 2 of 3 over 7 to log base 2 of 3 minus log base 2 of 7, yes? Well, it told us what log base 2 of 3's value is, yes? It is 1.585. And we're subtracting from it log base 2 of 7, which is 2.807. Now we just subtract. 1.585 minus 2.807, yes? Yes.
Should we put the whole log?
Possibly if they do give you that there. But here we're just wanting to use the properties with it. Now it might be a little off for this here, but it worked for the most part. Yeah, luckily for this here, they did give us a base of 2, so we could probably use the log base to calculate it and get close. Some of them might give us the exact answer with 3 digits. Some we have to round or try to figure out the rounding part. I could see on the college algebra course, they're switching it to log base A of 3 and log base A of 7, and we're going to do the same thing. And it removes our ability to actually calculate this. Does that make sense?
Okay.
Or we could just use the calculator to jump to the answer.
So we can do it and write it out.
Yes. Well, for the most part, these aren't too bad. Because 21, using 3 and 7 with multiplication, division, or powers, how could we rewrite 21 using 3 and 7? Because 3 times 7 is indeed 21. So we do have two things we multiply together inside the log, yes?
Yep.
So we can rewrite it as log base 2 of 3. All right. Yes. So log base 2 of 3 plus log base 2 of 7. Well, log base 2 of 3 is 1.58. We're add to it 2.807. And now we just need 2. So we can say 1.585 plus 2.807, which is 4 points. Questions on A or B? Are you ready for C? So how can we rewrite 49 using 3 and or 7? This
7 times 7
7 times 7 or 7.
squared.
But 49 is indeed 7 squared, yes? So from here, we can use which property? Product, quotient, or power? Power, because we can move the 2 out front. 2 log base 2 of, well, again, log base 2 of 7 is 2.807, yes? So now we just need to multiply that by 2. 5.614. 614? That's it. Questions on this here? We good with these 3 here? Yes? We'll look at 3 more. Now there's probably one on the homework that it gives you a number and you do have to divide to get it. Because if we said 10 and 2 and they wanted a log of 5, well, that's 10 over 2. We can divide them. But luckily for us, the first one here, log base 3 of 4/5. Log
3 of 4 minus log base 3.
Yes. Log base 3 of 4 minus log base 3 of 5. We're using our quotient property, which would be 1.262 minus. And at this point, we can plug it into the calculator. Which would give us negative 0.203. 262 minus 1465, which is negative 0.203. Our next one, log base 3 of 20.
What do you use logs for in like
Log base 3 and then 4 plus log base 3 of 5.
Okay.
Oh yeah, we could do that.
Yep.
A math teacher.
Yeah.
Oh well, of course, but like primary.
Currently, on the top of my head, I don't have too many examples of it. The scientists sell, because not half-life, logarithmics, it'd be looking at the inverse of an exponential function. So certain things grow at an exponential rate. Some things decrease at an exponential rate. Half-life, uranium, radioactive elements. But for this one here, we're going to do almost the same thing as A, but instead of minusing, we're going to add. Here's a 1, 6. We should get 2.727. All right, let's look at this next one here.
Oh, 5 times 5.
Or we could say 5 squared. Here we could
2 log of
say
log base
3 of 5, which is going to be 2 times 1.465. 0, carry the 1, carry the 1. And it should be 3.93. Yeah. Nope, 2.93. Because 5 would be 10, 12 so 3, 8, yep, 2.93. New parentheses 1.465 is 2.93. Questions on how we use these properties to evaluate these here? Are you ready for the last thing?
Yes.
All right, are you sure you're ready for change of base? Change of base. Log base C of A equals log base B of A over log base B of C. So, with this here, we can change the base to be whatever we want. Normally, we change that base to be whatever we started with to base 10, to go to common logs. And it works out that this is also the same as natural logs. So, let's actually look at this. So our first one is log base 3 of 8. If I want to write this in common logarithms with base 10, this here would change to log of 8, the top, or what's inside, goes on top, over log of the base.
That's it.
Now we can change it to natural logs. So this is the same as the natural log of 8 over the natural log of 3. Questions on this here? And if we wanted to calculate this, we could grab the 30xs and use the log button. Log of 8 over log of
That was 1.89.
1.893. Now, if we said log of 8, natural log of 8 over the natural log of 3, we get the exact same thing, 1.893.
Oh, that's it. Oh.
Who wants to do the next one?
Log base 11 over log base 7.
So log of 11 over log of
Oh, I don't have to say base.
7. So the base, because the base is 10, and since it's understood to be 10, we don't have to say it. Now, if we change this to natural logs, it would be the natural log of over the natural log of 7. And then if we wanted to evaluate it, we just stick it in the calculator and let it do it for us. Questions on this one here? So how would we rewrite log base 6 of 24? Log of 24 over log of 6, which is the same as
Natural log of 24 over natural log of 6.
last one, log of
19 over log of 2.
questions. That's it.